Hi everyone, I'm Jonas. I'm here in North Island today, and I'm here because I thought that since I'm just leaving Dublin for good in like 3 days, I thought that I wanted to give back a little bit, and almost everyone has been bathing or like swimming at the beach there when it's clean. Almost everyone has been walking around the dunes, trying to watch seals, trying to watch birds, but no one knows about this spectacular estuary and salt marsh that you have here between North Island and the mainland. So I thought that I might do a 10-minute video about like the main things of this estuary. Now, the first one, when people arrive here, usually the first thing that comes to mind is, why does it smell like rotten eggs? Now, let's try to answer this question. So most river deltas, where river ends, where river meets sea, that's an estuary, they are usually formed by salt, by sand. They are formed by very small grain, that water that doesn't really have much of that energy that it had upstream in the mountains, where we see these waterfalls, where we see these rapids that people like to canoe on or to kayak. Here, when at the end of the river, it doesn't have that strength, so it usually only carries really fine grain. Here we find even finer grain. We don't find salt, sand, we actually find silt, and we find clay, which are remarkably interesting, actually, kinds of sediments that one can find, because they have really complex structures, but I don't know anything about that, so I'm not going to talk about it. What we're going to talk about is, when you look deeper into this, you actually find that there are a lot of algae and a lot of sticks embedded into this soil, and a thing you don't really realize is that it also has all the chemicals and all the microscopic things that water brings. Apart from the leaves, apart from the silt, you also have all the fertilizers that are used upstream, and that's the part we're going to be focusing on right now. Because from freshwater, when you enter here, there you've got salt water. And what's this estuary? This estuary is going to become a gradient of different salinities, and with these changes in salinity, pH is going to change, redox potentials are going to change, and thus all the solvent properties of water are going to change. Things that were previously dissolved, or dissolved, are going to sediment and are going to come to the bottom. And things that were previously confined into these compounds, which were solid, are now going to dissolve into the water. And that's going to change progressively. So what forms here is actually this melting pot of all of these chemicals and all of this residue, of everything that the river has picked up on its path from the mountains down here. And so what happens when all of this organic matter and all of these fertilizers actually arrive here and start either dissolving into the bay or staying here? Most of them are going to form compounds, either with heavy metals or with any other kind of stuff that's here, and their eventual increase over the normal levels or over the normal concentrations of fertilizers that you would find here are going to make bacteria that eat this proliferate way more than they usually would. Sometimes good bacteria, sometimes bad bacteria, and sometimes the thing we are going to actually see with our eyes, which are the cyanobacteria and the green algae. They are going to find this to be their perfect place to grow, and that's why I'm going to do here now a panoramic view of this. It's full of green algae. Why? Because this is absolutely perfect for them, because it's filled with nutrients for them. And so what's this stench that we were talking about earlier? That stench is the hydrogen sulfide, which is it's the thing bacteria excrete. It's their waste material. So that's what causes the rotten egg smell. Now, even though it smells a little bit funny, it's a really interesting place to study because it actually has two estuaries in one. This would be the first one and this would be the second one. So here you have, okay, South Peninsula. So if you see, okay, an estuary is where a river meets the sea. So the northern estuary, okay, we have the water that comes from South Peninsula, which is not really industrialized except here for a little bit in Sutton. But not really industrialized. It's pretty clean. This is a natural reserve as well. And as you see, like, this is the Noble Island Special Protection Area. So all of the water that's coming here is actually coming from a special protection area. And here we have the Santry River. Oh, fuck, here. The Santry River, which starts on the Dublin airport. So it's not really like going through any fields or like massive factories. It's really small. So this is a really good place to study how in this ecosystem we have like how clean water behaves. Now, this documentary has been filmed here. Okay, here we have the Nanican River, which is a bit longer, and also where is the southern water coming from? It's coming from Dublin Port, River Liffey, which is a massive river which starts all the way there with loads of tributaries. And so this water is going to be reasonably more polluted, and this water is going to be reasonably less salty, like more fresh. So because of the Liffey River. And so when the tide goes down, okay, so this is going to be emptied, and when the tide comes back up again, it's going to be filled. But during the whole time, we have both Nanican River flowing through this to this place, and the Santry River flowing to this place. So we have here two different gradients. No, from the middle outwards, we're going to have the gradient of salinity for polluted water, and here for cleaner air water we also have the gradient for salinity. So this is the x-axis. No? What about the y-axis? On the y-axis we're going to find that these places that have been marked, these are the special protection areas for the salt marsh, which is protected, as well as the tip of the island. So all of this is very, very, very protected. And I think it's not clear, but I think it's because around this part of the island you actually have some groundwater which comes from here. The golf clubs that are here use a lot of this groundwater, but I think that this salt marsh is actually found here because of the groundwater that emanates from under the island. I'm not sure though, so don't really trust me. But in the y-axis we find this hydrological difference, which is really important, and that's why here you have a mudflat, no? And here you have salt marsh, and also you're going to find different species of algae, because the center it's going to be flooded a lot of the time, no? Because this is B-shaped, no? Like this is a little bit, let me see if I can, this is kind of B-shaped, no? So here there is going to be a lot of water all the time, and that this is going to be dry most of the time. So different species are going to be found across this y-axis as well as across this x-axis, because this is more fresh and this is more salty. So let's see an example. Let's dive a little bit deeper into this process that I talked about before. This increase in the fertilizers and the organic matter found in the water that then causes an increase on the bacteria that are here. So this process is called eutrophication, and its evil brother sibling are harmful algal blooms. These blooms are explosions of cyanobacteria, phytoplankton, green algae that you can actually see. And the thing is that these organisms, they free into the water, they liberate some toxic substances. They are usually not a problem, but when they reach high enough concentrations, because there's so much of them, they can actually turn the water into unsafe to swim in, and they can turn shellfish and crabs poisonous. And there have been reports, since this is a key place for many of the living cycles of the fish we eat, there have been reports of fish that have spent too much time on these poisonous waters or eating these poisonous shellfish. These fish have turned poisonous as well. And it's not just because of us and us wanting to not be close to poisonous animals and poisonous water, but this salt marsh that is here, it's actually one of the key places for bird migration. That's why it's protected. It's actually one of the key places for a lot of fish reproductive cycles. You all know that North Bull Island is a key place for seal reproduction. They raise their cubs here, they come here to reproduce. So this is actually a very, very important place that is being, its chemistry, its biogeochemical cycles are being heavily altered. And that's just one of the many examples of how factors come into play together in melting pots like this one. Imagine if we started looking at these biogeochemical cycles I talked about before. If we started looking at how mercury, for example, a heavy metal, or nitrogen, one of the key elements in life, behave in flooded soils like this one, where for now let's just see this little thing. No, the top part is reddish, the top part of this soil. Well, it's not reddish, but it's definitely more a different color than when you come down and you see it. Like, just as you drive your finger through it, you will realize that this surface color, it's just for like half a centimeter, and then since this soil is flooded, you find iron here that has been reduced, okay, layer. It has been oxidized. Why? Because of the oxygen in the atmosphere. Now, because this is flooded, the oxygen from the atmosphere cannot reach deeper down, and so here we have this redox gradient. No, this for those who have studied a little bit of these redox reductions, they are extremely important and affect almost every element important for us. Now, I was reviewing the footage now, and I think it's important to note that this poisoning, it's nothing else than just like a bellyache and maybe diarrhea in some of the worst cases. But well, most of us have experienced shellfish poisoning at some point, so I'm sure you can imagine. But like, it's not like poisonous, but it's a bit poisonous. Now, let's dive into something a bit less specialized, or more special, a different topic, which is, what's all of this? No, what are these things? What is algae? What are algae? So I'll start by saying that they are not plants. The main difference that you are going to find is that they do not have roots. Why don't they have roots? Because they don't look for nutrients, they don't look for food inside the soil. They look for food inside, they look for nutrients inside the water. Why? Because water is actually a great solvent, which air isn't. Because oxygen, well, air, no, I'm not gonna dive into that. But water is a great solvent, and water is dense enough to carry particles. So it wouldn't make really sense to look for nutrients inside the soil. It makes sense to go up the water column, no? Up. And that's why these algae here, these brown algae, these fucoids, that's the family Fucaceae, they have these air bladders. If you hear, oh no, that one, okay. This one wasn't an air bladder, like an air pocket. This was actually where they reproduce, the reproductive place. But this one is, I think. Pop, pop. You hear the pop? Pop. Listen. These algae here, these Fucaceae, they actually have sperm like us. A little bit different because they are dinoflagellate. No, they have like different flagella. You know, the little tail of the sperm, that's different. But They're really similar. They are actually sperm, and they are produced in the tips of these. So, well, I'm diving into tangents here. So you have three main parts, which are the blades. Okay, this is the blade. Then you have the stipe, which is, okay, you're going to see it better in this one. You have the blades, okay, the arms, the stipe, which is a little zone here that actually attaches the blade to the holdfast. What's the holdfast? The holdfast is where the algae meets the substrate or the rock. They are always, algae are, not always, in most cases, attached to rocks and to hard, very robust surfaces to not float off. Of course, you're going to find some examples of algae that are floating off, but even these, in some cases, they do have holdfasts, just they are really not strong, so they just detached. But well, these are the three main parts of the algae. And of course, in this Fucaceae, you also have the, as we said, the reproductive parts and the air bladders, which you can pop, like the plastic thing that wraps. I don't know if you know what I'm referring to. Now, some Fucaceae, they actually have tissues, but that's not the main, like that's not the norm for. No, that's too strong. That's not the norm. Usually the thing algae have is a single cell type forming these pseudo tissues, or like not tissues at all, and they just seem like they are making tissues. And sometimes you actually find algae that are a single cell, like I presume these ones. I wouldn't know for sure, but many of the filamentous, okay, the filaments, they are going usually to be formed by a very long single cell. I would need my, I left them at home. I have these binocular magnifying glasses to look at that, but I left them. And I also left my algae thingy. Well, so algae, they are basically three types: red, green, and brown. So brown, green, and red, we wouldn't find them here. We would find them maybe in the salt marshes, maybe in rockier bottoms. You also have the cyanobacteria, which we talked about before. They are basically like similar to green algae, and that's about it. Many species of algae, well, algae are found everywhere because lichen is found almost everywhere, and lichen is actually a friendship between algae and fungi. I don't know the pronunciation. It's so lichen. It's like a symbiotic relationship. So you can find them everywhere. These cyanobacteria, which are algae, almost. See, this is where we're getting into that, like the taxonomy of algae. It's super complicated. It's nobody really knows. Like everyone disagrees on this topic. For example, Fucaceae. Okay, these have a thing that is cryptic diversity. What's cryptic diversity? These are distinct species. Okay, this is what we would call Ascophyllum nodosum, and this is, I think, Fucus spiralis, but I wouldn't really know. Imagine they are that. Okay, so these are the morphological categories. But if you look at the genes inside each of these algae, no, you're going to find that not all the cells of a Fucaceae have the same genetic information. As humans, okay, we have the same genetic information inside all of the cells of our body, and that's what makes us an individual. But these algae do not, and moreover, these algae do not, like, not all of their cells are from the same species of Fucaceae. So you have these algae formed by different species, but they are the same individual, and you have no way of knowing just by looking at them. So increasingly this one popped good. Increasingly in recent years, all of the taxonomic research of algae is turning into just genetic trials, because they are so complicated, much more than us genetically, taxonomically. It's all actually crazy, and you have all of this here, and nobody looks at it. Now look at what I found. I found a blanket. This is one of my favorite genera. These are Ulbaceae. These are ulbals, and this is a huge one. I came here like a month ago, and because I wanted to collect some algae for my personal herbarium, for my collection, and I thought this might be like Ulba gigantea, which is obviously like giant ulba, but I think it isn't. And that's the thing. These ones are also cryptic. You wouldn't know, but these are from the same genera as this here, which is Ulba intestinalis. You know, you have all of these crazy morphological differences between algae, and they turn out to be the same. And these ones in the tips, you're actually also going to find these reproductive structures that I talked before. But these reproductive structures that you could also find in Fucaceae here are made by the same cell type. So it's just like, we could be talking about for hours here. If you want me to make like more specific videos about algae, I'd love to. I don't know much, but more than you. No, maybe not. But it's a really fun topic. I'd love to make more videos. I also wanted to say that the way I worded that, it sounded as if I was saying that algae are these super intelligent beings, no, that said, oh yes, of course, it doesn't make sense not to grow a trunk, but they are obviously not. I suppose someone actually tried to grow a trunk, they just died, and what you end up is like these guys, no, that tried out the flexible blades, the air bladders, they survived, and these other guys that tried being like really morphologically simple, they survived. So like evolutionarily, nothing makes really sense. It just makes luck, no? If I'm making myself understood. So, actually, I don't know if I explained this good enough. Like these air bladders that you find here, they use them, like they inflate them and they use them to actually cover more space, since like you're always going to find this vertical competition, no, in plant forms, even though these are not plants, or many times you're going to find this vertical competition. And now here, since it wouldn't make sense not to build a trunk because you have like these strong currents and water is more dense, so you can actually float inside of it. Well, you have these bladders that help them come up. I saw something cool here. What's this? Oh, it's just a rock. A very cool rock. It's filled with these other type of algae, this green algae, that it's actually well, whatever. This is the end of the Nanaking River. The salinity in this area is actually going to change during the day as the tides change as well. So it allows for some really cool adaptations. And look how beautiful. Look at those algae there. Freshwater? Salty? Who would know? And this is the salt marsh. As you can see, some remarkable plant diversity. Coastline. Well, at the end of the video, I also wanted to add thank you very much to all the people in Dublin for this amazing year that I've had. Thank you very much for the Irish people also for paying for my year in Trinity College, which is a public university. And I love that I, as a Spanish, have the opportunity to come here to Ireland, to immigrate here to Ireland to study. And I say this because I have a growing concern in Europe right now for the disdain we have towards immigrants like me, because I might be white, I might be European, I might be legally here, but that's only because we made a pact, you know, and it doesn't really make a difference. Everyone is born onto the same planet Earth, which is the very beautiful almost everywhere you go, except where humans build. And yeah, I don't know, especially Dublin, it's been kind of bad this year. I've seen it, and I just wanted to say thank you and bark. Thank you, bye bye.